All right, let's dive right into this explainer. Today, we're unpacking a mid 20th century botanical mystery that, honestly, completely defies the traditional laws of science. I mean, when you think of a forest, you picture sunlight, right? You think of these sprawling, lush canopies just basking in the rays, soaking up all that solar energy so they can grow. But what happens when you remove the sun from the equation entirely? Well, you get what scientists once thought was absolutely 100% impossible. We're looking at a story of extreme survival right here on our very own planet. 0.1%. I really want you to let that sink in for a second. That mind-boggling statistic, that is the absolute maximum amount of surface sunlight that ever penetrates down into the deep ocean ecosystem we're exploring today. Just a tenth of a single percent of the light you and I experience up on the surface makes it this far down. By all known rules of biology and botany, this establishes the utter impossibility of a forest surviving there. I mean, plants need light to photosynthesize, right? To feed themselves, to literally exist. So an environment with only 0.1% of sunlight should be a completely barren wasteland. It should be entirely empty of plant life. But nature, as we're about to see, has a really funny way of completely ignoring our rule books. And that brings us to this incredible historical discovery. Right in the middle of the 20th century, deep-sea divers were exploring the ocean's depths, totally expecting to find, the usual sparsely populated deep-sea environment. But instead, they stumbled onto something magnificent and just entirely baffling. Plunging down 150 meters into this dark, freezing cold zone, they found massive, towering kelp. We're not talking about a few straggly weeds here. This was a thriving, giant forest ecosystem. Just imagine being one of those divers for a second, descending into the pitch black, surrounded by freezing water, and suddenly your flashlight catches the towering stalks of a massive underwater jungle. It completely rewrote everything we thought we knew about where plant life could actually exist. Section 1. Entering the twilight zone. So the specific geographical space where these impossible giants live is known as the mesopelagic, or the twilight zone. This is literally the ocean's border between light and absolute darkness. And it is an eerie, incredibly harsh environment. The water pressure here is intense, the temperatures are absolutely frigid, and as we just established, the light is practically non-existent. It raises the stakes of survival to the absolute maximum. Traditional plant life? It would simply expire down here in a matter of days. It's a profoundly hostile place for anything that relies on photosynthesis. Section 2. Deep Sea Survival Hacks. Now, there is a really stark contrast between these two ecosystems. When you look at shallow water plants, they are living in a completely different world. Because they're bathed in sunlight, they can afford to expend energy converting bicarbonate from the ocean water into a usable form of carbon for photosynthesis. It's a super energy-heavy process, but hey, they have the sunlight to pay the bills, so to speak. But our twilight kelp, they absolutely do not have that luxury. Every single drop of energy they have is precious. So instead of wasting their incredibly limited reserves converting bicarbonate, they've evolved this completely different strategy. They just rely on the passive diffusion of the high concentration of free CO2 that naturally exists down in the deep ocean. They literally just let it flow right in. And this brilliantly illustrates their overall game plan: extreme energy thriftiness. By passively diffusing that free CO2, they waste absolutely zero energy on processing bicarbonate. It is an incredibly elegant, effortless solution to a massive biological problem. But actually, that's not their only hack. Because they live in near total darkness, they get to completely ditch another really costly process. See, shallow plants are constantly bombarded by intense UV rays, which means they have to spend energy producing a kind of chemical molecular sunscreen to protect their cells from excess light damage. Down in the twilight zone, excess light is definitely not an issue, so the twilight kelp just doesn't bother. They cross molecular sunscreen right off their biological to-do list, which saves even more of their precious limited energy reserves. Section 3. The winter digestion. Okay, so we've talked about how they manage to survive with just 0.1% light. But what on earth do these plants do when winter comes? The answer is this truly mind-bending hibernation procedure. Step 1, when the lights go out completely for the winter, they completely suppress their respiration. They essentially shut their biological engines down to an absolute idle, stopping almost all outward activity. Then, step 2, they switch their diet. Instead of trying to gather energy that just isn't there, they begin to slowly, methodically digest the carbon reserves that they managed to store up during those slightly brighter summer months. They are literally living off their own savings account, just riding out the months of darkness until a tiny sliver of light finally returns. It is an absolute masterclass in biological patience and efficiency. Section 4. crucial climate refuges. Now, it's fascinating to look at how these plants survive just as a biological curiosity, but there is a much bigger picture here. The vital takeaway is that these impossible forests are acting as crucial, stable climate refuges right now. Think about what's happening up on the surface. Ocean temperatures are rising, and marine heat waves are just devastating shallow water ecosystems. Those shallow species are finding their natural homes becoming completely unlivable. So where do they go? They flee downward. They escape the heat by migrating into the depths, and waiting for them down there are these massive, towering twilight kelp forests, providing food, shelter, and a stable, cold haven. These deepwater forests are serving as a literal lifeline for the ocean's broader biodiversity. So, to summarize the core takeaway of this whole explainer, the deep sea holds some brilliantly elegant evolutionary solutions. The resilience of our planet's hidden ecosystems is just nothing short of awe-inspiring. I mean, we looked at a space that should, by all accounts, be entirely void of plant life, and instead we found a towering forest that figured out how to hack its own energy consumption, entirely skip the molecular sunscreen, and literally digest its own carbon storage in the pitch black of winter just to survive. And in doing all of that, it created a massive safety net for countless other marine species. It really changes your perspective on the adaptability of life, doesn't it? Which leaves us with this final, incredibly provocative question. If massive, towering forests can thrive in a freezing, high-pressure zone of absolute darkness simply by rewriting the rules of biology, what other impossible life is just waiting to be discovered down there? We've only mapped a tiny fraction of the deep ocean. The twilight zone is literally just the border. So what brilliant, rule-breaking evolutionary hacks are currently lurking out there in the uncharted deep, just waiting for a diver's flashlight to finally pass over them? It's a vast, dark frontier, and we are absolutely only just beginning to scratch the surface.